Hello, hi guys. Today I would like to show you how to write a kernel module. But before that, let me give you some introduction. So you must have seen tons of videos and tutorials on the internet regarding how to write a simple Hello World kernel module for the Linux kernel. However, for people who want to go a few steps ahead and dig into some or delve into some complex things, this module I think would be a good start for them who want to go inside, who want to delve into kernel programming and writing even complex modules uh, or even the drivers. So this in this module, I will be showing you how to read the temperature. So every device, a machine, computer comes with a temperature sensor which senses the temperature of the CPU, and that is required for cooling purposes and also on the devices whenever the CPU temperature it goes beyond a certain point. The number of tasks that are scheduled on the course is reduced so that the temperature can be reduced, and there is always a check that is kept on the CPU temperature so that it should not reach a certain point, or else it will probably burn the chip or the board on which the CPU is mounted, or it might render it useless later. So today, what we will be doing is we will be just going over the thermal module, the thermal code, the that is the code which handles reading this temperature and doing some other things in the Linux kernel. So I'll be using tool called Elixir, bootlin Elixir. That is a very good resource actually for going over the Linux kernel. And let us dive straight into it. And what we'll be doing today is we will be just reading the temperature of uh, the temperature sensor on a Raspberry Pi 4B. So I have a Raspberry Pi 4B running Raspberry Pi OS 64-bit OS and connected via SSH, and we'll be writing the code for the module and running the module, and we will be checking the output message. So uh, yeah, let us move on to the code then. uh, this is the file that you need to look into for anything, or basically the base for anything you want to do related to the thermal component of the kernel, which is thermal.h. Okay, so this file contains some important structures called the thermal zone device, as you can see over here, and then there is also a thermal cooling device, and then there is a thermal instance. So there are so I would say the first structure over here, thermal zone device, is what we are going to use. So let me go to this structure over here. And before we go to the thermal zone device structure, I will also show you this important structure that is called thermal zone device ops. That is the thermal zone device operations. So there are certain important functions like get temperature and set trips, or hot, critical. These are basically callbacks that you will be called when certain conditions are met. Okay, basically when the temperature goes or falls beyond a certain point. And then we have operations for the cooling device also. So uh, these these are also functions that you can call when you want to cool the CPU or any thermal zone basically. So a thermal zone basically means that any temperature sensor on your machine basically. There can be many thermal zones. So there can be one for the CPU, there can be one for the entire motherboard on bigger PCs, there can be one for battery. Even battery has uh, even your battery you might have seen on your phone or your laptop, it heats up. So you might want to uh, monitor the battery temperature. There can be several temperature sensors on a machine. And so Raspberry Pi 4B, which is the BCM Broadcom 2711 SoC, it comes with only one temperature sensor, and we will be reading the temperature using that sensor. So what you can do is you can also read the temperature using the sysfs using the sysfs interface. So I can just show you quickly how we can do that. I have this SSH over here. So what I can do is I can do a cat followed by sys class, and then this thermal zone zero, what you are seeing, right? On your PC like x86 based PC, you might see several thermal zones because there are several temperature sensors on a bigger machine. But on the Raspberry Pi, you will only see one thermal zone, that is thermal zone zero, and there is a file called temp, and if we read that file, the temperature is output in milli centigrade. So basically, 41,868 means that the temperature is 41.868 degrees Celsius. Okay, so that is one way you can read the temperature from the user mode, but I will be showing you how to do it from the kernel mode. Okay, so for that I'll be showing you how this temperature is read in the kernel basically. So if you go, this is the structure thermal zone device. Okay, and it has several members, but the most important member that we will be using, or we should know, is thermal zone device ops. Okay, because that is how the temperature is read. You might recall the get temperature function is a member of thermal zone device ops. So let me uh, type this function for a minute. So in our code, in the code for the kernel module, we will be requiring a reference to the thermal zone device, to the structure thermal zone device, which is our temperature sensor on the SoC, and is uh, that is got by using this function in the thermal.h file, which goes by the name thermal zone get zone by name. Okay, so we will also go through uh, another file, uh, which is basically the driver on the Raspberry Pi 4B for reading the temperature. So we should head over to drivers. Mm, drivers thermal. Then we have to go to Broadcom. And in Broadcom, we can see that there is this file called bcm2711 thermal.c. That is our driver. Uh, Over here, let me show you how this driver is reading the temperature. So this is the bcm2711 get temperature function. Okay. So what happens is this function uses the PID method. You might be knowing the PID controller. So it does some calculations based on the slope and the offset, and it calculates the temperature. Okay, and it returns the temperature in a pointer that is passed to the function. Okay, and how we register this callback is how we register this function is in this structure. It is shown that get temperature is basically bcm2711 get temperature. Okay, so what it means is uh, over here in the include. Yeah, so this function inside thermal zone DevOps, that is set to this function. Okay, and how we read this is also another good thing to know. How it just output this when we try to read the file is also a good thing to know. So what we need to do is we need to click on this. And yeah, this Elixir is kind of very good. It just gives you all the available, all the places where this function is called. Okay, so we can head over to, so we can head over to this uh, drivers, and then there is thermal sysfs, and then there is this function called temp show. Okay, so whenever you are trying to read the file called temp, okay, what it does is it internally calls this function. Okay, and uh, inside this temp show function, what is called is thermal zone get temperature function. Okay, thermal zone get temperature is basically a part of thermal.h. Okay, so this is the function that is defined in the header file, and it takes an argument as a pointer to the thermal zone structure, thermal zone device structure, and the temperature. Uh, and over here, whenever you try to read the file, this function gets called thermal zone get temp, and this function internally calls another function, thermal zone get temp. It internally calls this function thermal zone get temp. Okay, and if we click on this function, you can see that it finally calls this get temp function, which is basically the one that the driver bound it to. Okay, so this is basically the flow of how the thermal zone get temperature function works. Okay, so we are going to use that function in our code. Okay, so let us get our hands dirty and head over to the code. So this file actually I'm editing on my laptop, but I already have a copy of this file on the Raspberry Pi, and I'll be just building the module over there, and I'll be showing you the output. Okay, so let us start with the basic stuff that is required, which is uh, including. And okay, so let us head over to coding. So we'll start with the basic stuff. So I'll have to include these files, linux module.h. So we are including this thermal.h, which is required as I showed you before. And we will also be needing this error.h, because we need to do some checks on the pointers. So we'll start with the init function, static. So I'll call my function thermal module init. So I'll start off by defining the pointer to the structure, thermal zone device. Let us call that TZ, and then we need a pointer for the temperature, and then we also need we don't need another int. So TZ equals thermal zone get zone by name. Now, one important thing you need to know is the name of a thermal zone is actually the uh, name, the string that is present in the file which I'll be showing you right now. Uh, the name of the file is, so I'll show you how to get this name, the name of the thermal zone. So what you need to do is you just need to read the file called type, okay, inside the thermal zone 0 directory. So let me type that cat sys class thermal zone 0. So as you can see, the name of the thermal zone is CPU hyphen thermal. Okay, so we will be typing that over here. Okay, now we just need to put a check on this thermal zone pointer. So let me use this macro. Sorry, it's an inline function. on the pointer, and in case of an error we need to print failed to, okay, and return immediately. Now what we need to do is, if we have got a valid pointer, we need to go ahead and read the temperature. Thermal zone get temperature. uh, we'll pass in the pointer and the address of our temp variable, and then we will just print it. And if all goes well, we'll just return 0, and that is it with our code for init. Now what we will do is, we need to write the exit function, module exit function. We'll just print that module has been removed. Forgot to put in a new line over here and over here. Okay. After that, we just need to set these functions. So module, and module license. Okay. So that is all with our code. And also, for the sake of completeness, let me show you the make file that I am using. Mm, So in this make file, I am just building this object read temperature.o, and the all and the clean rules, they are self-explanatory. You will also find them in any Hello World module tutorials also. So let me just exit this, and let me make this module. First, let me do make clean. Okay, let me make the module. Okay, module has been built successfully. Now we just need to insert it. So sudo insmod readtemp.ko. Okay, module has been inserted. Let us head over to the messages. Let us type d message and see the temperature. So as you can see over here, the temperature has been read. Thermal zone from temperature from thermal zone device 0 is 40.894 or 40,894 millidegrees. Okay, and so I think that's all with our module. Uh, Although this is a simple part of what you can do by reading the temperature, there are much more powerful things that you can do. Let me show you say an example. If we head over to this header file, and if I show you this ops, okay, so you can set the trip temperature, you can get the critical temperature. So these are basically some thresholds that have been defined, and certain actions are triggered when a threshold is met. Okay, then there is this bind unbind. So basically what you can do is you can actually uh, create a project on your Raspberry Pi, wherein you can let us say the temperature of this CPU, if it goes beyond 50 degrees Celsius, say, what you can do is you can start a fan that is connected to the GPIO of the Raspberry Pi, and yeah, the fan will turn on whenever the temperature exceeds 50 degrees Celsius, and the fan will automatically turn off whenever the temperature goes below, say, 40 degrees Celsius. Okay, so these are the things that these are some powerful things that you can do to explore the kernel a bit further, and also you can have a proper cooling solution for your Raspberry Pi with a fan and using the GPIO. I have not shown the GPIO how to read and write to the GPIO pins from the kernel, from this kernel module, but there are some examples available on the internet where you can do that, and also on the Raspberry Pi forum you will find examples. Okay, so this is all I think for this video, and I'll come again with some another example on kernel module or kernel programming, and yeah, we'll learn a bit more on this. So thank you all for watching, and bye.